All right, today we're covering compound and absolute value inequalities. Okay, so this is just a review from the last lesson. So you have 7 plus 3y is greater than 4 times y plus 2. We'll distribute. You have 4y plus 8. I'm going to subtract 3y from both sides, so I get y plus 8. And then subtract 8 from both sides, so I get negative 1 is greater than y, but I like my y on the left, so y is less than negative 1. Again, this answer is fine, so we have a 0 and a negative 1. This will be an open circle, y is less than, so we go left, and then we're going from negative infinity, and we stop at negative 1, and it gets a parenthesis because it's an open circle. All right, now we're gonna look at two different types of compound inequalities. The first one we're looking at is and inequalities. And another way that you'll see these written is with an X in the middle, and then you'll see signs like this. So this is just another way to write that. Notice with an and inequality, the signs always go in the same direction. So you'll never have something like this, okay? That doesn't work. They have to go in the same direction. All right, when you're solving something like this, what your goal is to get y alone in the center. And what you do in the middle, you have to do to both sides. So we're gonna add 2, so that gives me 12 is less than or equal to 3y is less than or equal to 21. And then when you divide by 3 in the middle, you have to divide on the left and the right. So now we have 4 is less than or equal to y is less than, this should not be or equal to, just less than 7. Okay, so here's your final answer. When you graph this on your number line, so you have 0, 4, and 7. We have a closed circle at 4, an open circle at 7, and this reads that y is bigger than 4 and less than 7. So y is falling right in between 4 and 7. And then when you put the interval notation in for this, what you do, you still read your graph left to right. So our graph starts at 4, closed circle, so it gets a bracket. It goes to 7, open circle, so it gets a parentheses. All right, see if you can figure this one out on your own. I'm gonna subtract 5 all across the board. So now I have 6 is less than or equal to 2x is less than 12. And then I'm going to divide everything by 2. So now I have 3 is less than or equal to x is less than 6. Here's my answer. 0, 3, 6. Closed at 3. Open at 6. Bigger than 3 and less than 6. So we go in the middle. Bracket 3, 6, parentheses. All right, notice now we're shifting to a different type of compound inequality. We're looking at or. Or inequalities will never be written as one. So these are always two separate inequalities. And when you're writing out your answer, you have to remember to include the word or. Okay, so don't forget to write out the word or. All right, so here we have x plus 3 is less than 2, or negative x is less than or equal to negative 4. Okay, so now I'm just solving these separately. So I'm going to subtract 3 from both sides. So x is less than negative 1. I don't know what just happened. Hold on. Yikes. Okay, x is less than negative 1. The word or comes for the ride. Divide everything by negative 1 here. Rules for inequalities still hold true. So we divided by a negative, so I flip the sign. This whole thing right here is my answer. Now, since it's a compound inequality, both of these inequalities are going on my number line. So I have a 0, a negative 1, and a positive 4. So x is less than negative 1. Open circle, x is smaller, so arrow goes this way. X is greater than or equal to 4, closed circle goes this way. And then when you're doing interval notation, like you still have to do interval notation for these. So you're still reading your graph left to right. So your graph starts here. So we start with a negative arrow So it's negative infinity, parentheses, and we stop at -1, parentheses, because open circle. When you have a jump in your graph, you use a capital U, which is called the union sign. Okay, so that represents a jump in the graph, and then you just pick up where you left off. So now we start at 4, bracket, because it's a closed circle, and we end at positive infinity, parentheses. Okay, go ahead and try this one. X plus 5 less than 1, or negative 2x less than or equal to -6. We're going to subtract 5, so that's -4. Divide by -2, we flip because we divided by a negative. We have 0, we have -4, we have +3. Open at -4. X is less than, so it goes this way. And make sure you're actually graphing what your solution says. Like, read it out. Don't just draw lines and assume. X is greater than 3, so it goes this way. Interval notation, parenthesis at -4, jump in the graph. Oops, not that. Bracket at 3, end at infinity, parentheses. All right, now we're gonna spice it up a little bit, and we're talking about absolute value inequalities. So you're gonna see absolute value bars here. And there's 2 types of inequalities that you're gonna set up when you have absolute value. So the rule is you always start by isolating. Okay, this is always step 1, never do anything else first. Always isolate. After you're isolated, you get to choose whether you're setting up an AND problem or an OR problem. Here is your clue. If you isolate and you have a less than sign or a less than or equal to, you set up an AND problem. And the way that I remember this is less than. Okay, I have a less than sign, less than. I know it's corny, but it helps me. If you have a greater than or equal to sign, you set up an OR problem. And the way I remember this is greater, like greater. So that's your guide to which type of inequality that you have to set up, but don't forget to isolate first. Okay, here we go. So absolute value of 2x minus 2 greater than or equal to 4. It's isolated already, so now we figure out which type of problem we set up. Greater, we have a greater than sign, so it's a greater problem. So we're setting up an OR inequality. So here's how it works. Drop the bars, and then drop the bars again, flip the sign, set equal to the negative. So drop bars, drop again, flip sign, change to negative. Okay, now we just solve. So 2x is greater than or equal to 6. X is greater than or equal to 3. Don't forget the word or. 2x is less than or equal to -2. X is less than or equal to -1. So here's my answer. Now I graph. I have a -1 and a 3. Closed on 3 in the right direction. Closed on -1 in the left direction. My interval notation, I don't know what just happened. All right, my interval notation is, where's my pen? -infinity to -1, bracket, jump, bracket, 3, infinity, parentheses. All right, see if you can figure this one out. Absolute value of 3x minus 3, greater than 9. It's isolated, greater. So we go OR, drop the bars, drop again, switch the sign, make negative. Okay, add 3, divide by 3, bring the word down, add 3, divide by 3, answer. Okay, so 0, -2, and 4. We have open on 4, x is greater than. Open on -2, x is less than. -infinity to -2, jump 4 to infinity. I know I'm moving through these fast. Try pausing it, doing the problem, and then seeing if you get it right. All right, we got one last example here. Notice we're already isolated and we're set, it's less than, so I'm gonna do an and problem. So here's how you set these up. Drop the bars. Okay, next thing you do is you match this sign on the other side of the bars, or like where the bars were. So you have a less than or equal to sign. So you literally copy paste. Don't flip the sign. Don't flip the sign. Don't flip the sign. It should always go in the same direction. And then here you put a negative version of this. So now you have an and problem set up. So we're gonna go ahead and subtract 3 everywhere. So -7 less than or equal to 8t less than or equal to 1. Divide everything by 8. So now we have -7/8 is less than or equal to t is less than or equal to 1/8. There's my answer. Now we graph 0. We'll call this 1/8. We'll call this -7/8. They're both closed circles. T falls in between. Interval notation, they both get brackets. So it looks like that. All right, that's a wrap on compound and absolute value inequalities. Let me know if you have questions.